Hey Global Impact students, this is Mr. Ellinger, and today we're going to take a look at our first lesson in Unit 1. It's called Foundations for Algebra. This is an essential chapter. It's a building block for everything that we do in Algebra 1 and really the rest of your math classes here at Global Impact. So let's go ahead and get started. A couple big ideas in this unit. Number one are variables. Quantities are used to form expressions, equations, and inequalities. An expression refers to a quantity but does not make a statement about it. An equation or inequality is a statement about the quantities it mentions. Using variables in place of numbers in equations or inequalities allows the statements of relationships among numbers that are known or unspecified. Equations are used to represent the relationship between two quantities that have the same values. Another big idea are properties. A lot of the things that we do in algebra will be based on properties. In the transition from arithmetic to algebra, attention shifts from arithmetic operations such as addition, subtraction, multiplication, and division to the use of properties of these operations. All of the facts of arithmetic and algebra follow from certain properties. As I said, this is the first lesson in Unit 1, and it's titled Variables and Expressions. We have one learning target in this lesson, and that is to write variable expressions. Some essential understanding that you need to take away from this lesson. You need to understand that algebra uses symbols to represent quantities that are unknown or that vary. Also, mathematical phrases and real-world relationships can be represented using symbols and operations. Some background on this lesson. Algebra is a language that is comprised of symbols and letters. The symbols represent operations and numbers. The letters represent unknown quantities that vary. When symbols are combined into a mathematical phrase, the phrase is an expression, such as 15 plus 23. The expression 15 plus 23 always equals 38. When the variables are combined with symbols, the phrase is an algebraic expression, such as x plus 23. The expression x plus 23 equals different values depending on the number assigned to x. X is the variable. It's called a variable because the value of x varies. It can be anything. We use lowercase letters to represent variable quantities. One of the most important skills to gain in Algebra 1, and the most important skill in this entire unit, is to know how to translate mathematical situations written in words into useful mathematical expressions correctly, and vice versa. We have to be able to go from expressions to words also. So we have 4 vocabulary in this lesson. We have quantity, variable, numerical expression, algebraic expression. An example of a quantity would be a number, 3. Known quantity. If I told you you had 3 friends, then you would know exactly how many friends you have. It's a known quantity. If I told you that your neighbor has X friends at a particular point in time, then you wouldn't know how many friends they had. It's some variable unknown quantity. So quantities can be known, in this case numeric values, or they could be unknown and they are variable values. Numerical expressions are expressions that just have numbers in them. Algebraic expressions are expressions that have variables in them and numbers as well. So an example of a problem that we need to be able to do, a basic translation, is really what we're doing. It's like we're going from one language into another. We need to be able to translate a situation like this. What is an algebraic expression for 18 more than a number n? As always, there are going to be keywords that we have to know what they mean. A lot of times we don't like word problems. We don't like to take things that are in words and have to write them as expressions or equations or whatever to solve problems, because a lot of times we don't know what the words in the sentences are telling us. So we have to be able to interpret and translate those. Okay, so we have to know, in this problem, we have to know what the word more than means. Okay, so more than implies addition. So what we can do here is we can take our variable n, and more than we know means add. So we're just going to add 18 to n, and there we have an algebraic expression. The value of that expression depends on the value of n. It could take on many, many values depending on n's value. So here it is a table, some different words that we have to know what they mean. We want to be able to translate words into algebraic expressions. So here we have a bunch of, in this section here, we have words that represent addition. Here we have words that represent subtraction. For instance, the difference between x and 7. That's a subtraction situation. The word difference means in subtraction. So here we have x minus 7. 10 less m. 10 less than m. You can see these are switched, and that's interesting, and we'll talk about that here in just a few minutes. The order in which you subtract things matters. Addition doesn't matter. Subtraction definitely matters. Multiplication, we have some multiplication expressions over here. Again, we can multiply in any order that we like. We have words like times and product and multiplied. Another word that you'll see a lot as we get going in algebra is per. The word per usually implies multiplication. And then here we have some division situations. Words like quotient, divided by, divides. Ratio is another word for division. And here you have a couple interesting ones down here at the bottom. Separated into equal parts. That's what division is. 5 parts per 100 parts. Okay, you're dividing 5 things into 100 parts. Okay, so again, lots of expressions here. We have to know what they all mean in order to be able to translate words into useful mathematical expressions. This slide can be found on Schoology. There's a PDF document on there. You can either view it, reference it, or just download it and have it on your computer to reference it whenever you'd like. Here we have a sample problem. What is an algebraic expression for each word phrase in parts A and B? And we have a part C that we'll look at here in just a second. So part A says 6 times a number n. So the key word here, the operation here, is times. Okay, always identify our key word. So what does times mean? Well, we know times means multiplication. So we're going to take the number 6 and we're going to multiply it by n. And the way that we write that is 6n. Now, we know we could put 6xn. That's something that we do. You've done in the past. We use an x for multiplication. We can also use a dot, 6.n. Those are both correct. But in algebra and moving forward, we want to really try to stick to this expression here. X can get confused with the variable x. Okay, and a dot, sometimes it doesn't really confuse us, but it's just unnecessary. We want to try to minimize this, simplify this, write as little as possible. So it's just a good habit to get into to go with 6n. All right. Second example here for letter B, the quotient of 18 and a number B. Quotient. What's quotient mean? Well, the word quotient means divide. Here we have to pay attention to the order. The quotient of 18 and a number B. So that says take 18 and divide it by B. So we'll write it this way. Now, if those two quantities were reversed in the statement and said the quotient of B and a number 18, then we would have to rewrite our quotient B over 18. Part C, do the phrases 6 less a number y and 6 less than a number y mean the same thing? Explain. What do you think? So 6 less a number y, 6 less than a number y. So we have the extra word than in there. Okay, do you think that makes a difference or not? So I'll give you a second to think about that and maybe jot down the phrases that you think would represent that. The first phrase, 6 less a number y, is just simply saying take 6 and less a number. So it's less a number is just implied subtraction. Okay. Now when we add the word than in there, 6 less than a number y, we have to understand that it's saying start off with y and take 6 away from it. Okay, and you can see that those are two different expressions. Just to give you an example of what I'm talking about here, if I told you that, let's go ahead and find the value of these two expressions when y is 3. Well, in our first expression, we would have 6 minus 3, and that would equal 3. In our second expression, we would have 3 minus 6, and that equals negative 3. So you can see the order that we subtract matters. If we switch the order of subtraction, we will go from a positive value to a negative value. That's what happens. All right, a couple more examples here. What is an algebraic expression for each of the following word phrases? In A, it says 8 less than a product of a number x and 4. So here we're getting a little more complex. All right, we have 8 less than the product. So this is saying 8 less than a product. Okay, and over here it's telling us this is the product. Okay, so the product of x and 4, we write that 4x, 4 times x. We always put the number in front of the variable. Okay, 4x, 4 times x, the product of 4 and x. Now we want to write 8 less than that. So since it says 8 less than the product, we're going to start off with the product and we're going to take away 8 from that product. So we write 4x minus 8. Right? Part B, twice the sum of a number m and 8. So this is saying twice means 2 times. So we're going to multiply 2 times the sum. of m and 8. And this one's a little bit interesting. Since it's saying twice the sum, that means we have to have the sum first before we multiply it by 2. So how do we do that? Well, we go ahead and put our sum, and this is where grouping symbols come into play. So there's our sum, and we're going to take that sum and we're going to multiply it by 2. Okay, this may be a little confusing because we have 2 and then a set of parentheses. Well, it's implied when we write things this way that in this space right here there is multiplication. There's implied multiplication. We won't see an x, we won't see a dot, but we have to understand that this expression is 2 times this quantity. Inside that quantity is a sum of m plus 8. So this would read 2 times the sum of m plus 8, or twice the sum of a number m and 8. Very important stuff here. Part C, the quotient of 5 and the sum of 12 and a number t. So it's telling us that we're going to write a quotient. The 2 things in the quotient are the 5 and the sum. Okay, so the quotient of 5, since it says of 5 and the sum, we're going to put 5 in the numerator and the sum in the denominator. Well, we don't want the word sum. It tells us what the sum is. So we're going to put the sum in there. What is the sum? The sum of 12 and t, that's our sum. 12 and a number t. Well, we have 2 ways we can write this. We can write 12 plus t, since that's the way it reads on paper. That would be acceptable. Or we could put t plus 12. A lot of times once we get going here, we would just like to see that variable first, t plus 12, but 12 plus t would be correct also. We can add quantities in any order that we like. What word phrase can you use to represent the following algebraic expressions? So here we're going the other way. We're taking a known expression and we're writing it out in words. Okay, so part A, we have x plus 8.1. Well, we know a plus sign or an addition sign means sum. Okay, so one way that we could write this is we could write the sum of a number x and 8.1. Okay, and if you remember back to the chart that I showed you with all the different expressions for addition, we could write this in a number of ways out in words. We could use a number x plus 8.1 just as it really reads. We could write 8.1 added to a number x. We've got options here. All right, part B, we have 10x plus 9. Well, we have to know what's going on here with the 10x. 10x, we know there's implied multiplication there. So we know that this is 10 times x. And then we've got plus 9, so we know we're adding 9. We know we've got a sum here. So what we're going to do is we're going to write the product of 10 and a number x plus 9. That's one way to write it. Part C here, I couldn't type it in with the fraction of stacked fractions, so when you see n/3, we know that there it's n divided by 3, the fraction n over 3. So when we see this, we know that we're talking about division. So what we've got is we've got the quotient of a number n and 3. Here's an application problem of this. So suppose you and some friends are going to a museum. Each ticket costs $4.50. If n is the number of tickets purchased, write an expression that gives the total cost of buying n tickets. Okay, so if you think about this, we've got, we can think about specific values. If you have 5 friends going, 450 plus 450 plus 450 plus 450 plus 450 would tell us the cost of 5 tickets. A simpler way would be to take 450 and multiply it by 5. Repeated addition is multiplication. But this is asking us for a general case. For any number of tickets purchased, what would the cost be? So we know that there's multiplication involved, so we're going to take 450 and we're going to multiply by n. Any application problem, always want to make sure that our answers have proper units And if we're asked a question, we need to address the question. We weren't asked a question there. We were just asked to write an expression, so we're fine. Part B says, suppose the total cost for N tickets is $36. What is the total cost if one more ticket is purchased? So they're telling us N tickets cost $36. What happens if we buy one more ticket? Well, we know the tickets cost $4.50 a piece. So we're going to take $36 and we're going to add the cost of one more ticket. And that would give us a value of $40.50. So there's a simple application of this. Again, this lesson is critical to everything that we do moving forward. We have to be able to take words and express them mathematically, and we also have to be able to take mathematical expressions and equations and know how to verbalize them or write them out in words.